All right, let's look at one more factorization of a trinomial. The difference here is you have a y on the end of it, but that should not be a hindrance to you. You're going to actually work with those y's just like you did with the x's. They'll just be in the last position of each binomial. So, okay, let's just do the technique one more time, just to get a little more practice with that technique that we looked at in the prior two examples. So we're going to look at the leading coefficient. It's not a 1, so we have to use it. So 2 times this. Now, this is not a constant term, but it's the last term. So we're going to handle it the same way. Again, don't let these y's here mess with you. You'll see what happens with those in just a little bit. All right, so we're going to multiply these two values together. We get a negative 24. Okay, can we come up with two factors of negative 24 that when added together give you a plus 5? Well, wouldn't that be an 8 and then a negative 3? 8 times negative 3 is negative 24. Check. 8 plus a negative 3 is 5. Check again. All right, so let's go through the motions. 2x squared plus 8xy minus 3xy minus 12y squared. I mean, I'm including the y's here because they were there initially. That's really the only difference. And just stay with me and you'll see what happens at the end. It'll work itself out. Okay, so GCF here and then GCF there. GCF of the first two would be what? It looks like it would be a 2x. Then left over, we'd have a what? An x. And then what? 4y, right? It's going to work itself out. Okay, what's the GCF here? Well, we have to get this binomial to repeat itself. So I think it makes sense in this case to take out a negative 3, and what else? Y. So negative 3y is a GCF there. Again, you're making it negative so that the first term is clearly positive like it is here. Okay, they have to be aligned 1 to 1. Everything must be exact. So we're going to put an x here because that makes sense. And then negative 3y, what? Times what? Plus 4y, right? Wouldn't negative 3y times 4y give us a negative 12y squared? And it would. So again, these two binomials must match. They must be identical. Otherwise, you could not factor it. Okay, so whatever's out in front, group together. And then what's repeating, just write down one time. And you're finished with that one. The final thing we're going to look at in section 1.3 is formally the factoring by grouping process. Okay, now I've been actually showing you that, correct? I mean, in the last 3 examples, we looked at how to factor a trinomial by grouping using that technique. Again, you don't have to use that technique, but many of my students in the past have liked that process. That's worked well for them. There are, of course, other ways to factor trinomials. It doesn't really matter to me. Just be able to factor. Okay, so let's go ahead and look at our last example. This one is pretty much already set up for us to rock and roll, right? I mean, it's already 4 terms. So we're actually to the point in the process where all we have to do is factor out the GCF in the first 2, which would be what? What's the greatest common factor here? 3 and then a, right? And then what's left over? Well, we have a 3a times x would give us that. And then 3a times a negative 2y. Wouldn't that give us a negative 6ay? 6a. Yeah, it would. So we're good there. And then what's the GCF here? Well, to me, it looks like a b in some capacity, and it looks like a negative b specifically. Again, this remaining portion must match what you have right here. So x, that works. Negative b times x is negative bx. And then watch this. Negative b times a negative 2 would give us that negative 2b. And then all we have to do is add the y, and we're all set. So whatever's out in front, you group together, hence why it's called factoring by grouping. What's repeating, you write down just once. And we are finished with the notes for section 1.3. Hope you're having a good first week. Take care.